In the previous video, we talked about permutations, where order is important. And in this video, we're just going to talk about combinations, where the order is not important. So think about it like a bag of Gardettos. You reach into the bag, you grab some things out, you might get a couple pretzels, a couple of these brown things, some of these breadsticks, but you're going to end up eating the same no matter what order you eat them in. Pretzels, these brown things, and the breadsticks. So when you're trying to remember the difference between permutation and combinations, just think combinations, it doesn't matter what order you do things, you're still going to end up with the same combination of items. In math terms, that's generalized by this equation. The number of combinations of R objects taken from a group of n distinct objects is denoted by NCR and given by this formula. So it's n factorial divided by n minus r factorial times r factorial. So let's talk about a situation with cards. A deck of cards has 52 cards, has 4 suits, 13 different cards in each suit. If the order in which the cards are dealt is not important, how many different 5-card hands are possible? So the dealer is going to give you 5 cards. It doesn't matter what order he gives them to you, he or she gives them to you, because you're still going to end up with the same 5-card hand. It doesn't matter what order you get the cards in. So we know that this is a combination, not a permutation. And to set up the equation, we're going to say there are 52 cards, and we're going to get a hand of 5 cards. So n is 52, r is 5. That's equal to 52 factorial divided by 52 minus 5, n minus 5, 47 factorial times 5 factorial. Once again, when you plug this into your calculator, be sure you're using an obsessive amount of parentheses. You want 52 factorial on the top divided by 47 factorial times 5 factorial, and you should get an answer of 2,598,960 different combinations of 5 cards, which is actually pretty surprising to me. I didn't know that a 5-card hand in poker, there could be more than 2 million options for that. That's pretty crazy. The second question's a bit more tricky. It says, in how many 5-card hands are all 5 cards of the same color? So how many different ways can you have all red cards or all black cards? So we actually need to multiply 2 combinations together. First, we need to pick a card and determine what color it is. So of the 2 colors, we're going to take 1 color. And then we're going to multiply that by the cards only of that color. Then once we've established the color, we have 26 options. Sorry, 26. We have 26 options because that's half of 52. So half of the cards are red, for example. And from those 26, we're just going to take all 5 cards just from that color set. So we're really solving this problem first establishing that there are 2 different colors, and then once we do that, taking 5 cards from each color. So the way we solve this is once again using the formula we've established at the top. So we have 2 factorial over 2 minus 1 factorial times 1 factorial times this part, 26 factorial all over 26 minus 5, 21 factorial times 5 factorial. We're going to be very careful to multiply those out. I would simplify each part first before multiplying those together. And once you do, you'll get 131,560. That means there's 131,560 options for having a hand that's cards all of one color. So this is really critical. When you have multiple events, I took this straight from the textbook because I think it says it really well. When you're finding the number of ways both an event A and an event B can occur, you need to multiply like we did in that second part, part B of example 1. When you're finding the number of ways that event A or event B can occur, you're going to add instead. So we multiplied in that problem we just did because we were looking for the number of ways event A and event B can occur. But there might be some issues where we have to add instead. Before we take a look at this next problem, I just want to focus on these Gardettos for a second. I figure either or two things is going to happen. Either Gardettos is going to be pleased that I'm advertising for them in my video, or they're going to try and sue me. Anyways, Gardettos are delicious. Let's take a look at this next problem. It says William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, 18 are comedies, 10 are histories, 10 are tragedies. How many different sets of exactly 2 comedies and 1 tragedy can you read? So the first thing we need to do is decide, are we going to multiply these two events together? Because we're going to pick 2 comedies, then we're going to pick 1 tragedy. And this one says, how many different sets of 2 comedies and 1 tragedy can you read? So we're going to be combining those 2 things together, event A and event B. So we're going to multiply these 2 options together. So the first one we're going to write is, of 18 comedies, we're going to pick 2, multiplied by 10 tragedies, and we're going to pick 1. So I'm going to go ahead and simplify this a bit. We're going to have 18 on the top over 18 minus 2, that's 16 times 2. And after you get some practice with this, the formula is very easy to remember. 10 on the top times 9 times 1 factorial. Multiply those together, and that comes out to 1,530 different sets of 2 comedies and 1 tragedy. Second question is, of course, a little more tricky. It says, how many different sets of, at most, 3 plays can you read? What it means when it says at most is you can read a set of 2 plays. You can read 0 plays. You can read 1 play. You can read 2 plays. You can read 3 plays. So what we need to do is add these different situations together. So we're really going to add the combination of 1, 2, 3, and 0 together. Well, if you read 0 different plays, out of the 38, you're choosing 0. Plus, out of the 38, you're going to choose 1. Plus, there's a chance out of the 38 you choose 2. Or out of the 38, you choose 3. So we're going to really add all those probabilities together. Of course, I trust that you can fit it into this formula by now. And I'm just going to skip those steps for you. So when you put those into the formulas, you get 1 plus 38 plus 703 plus 8436. Add all those together, and so there's 9,148 different ways you can read at most 3 plays.